This is the Geometry Unit 6 Lesson 3 video. This unit continues to work through the different types of quadrilaterals. Last lesson, 2 lessons were all about parallelograms, and everything from here is going to be not everything, but the next few lessons will be subcategories of parallelograms, and I will post in the notes a little diagram for how these different things are related. But first thing you need to know about rectangles is they are a type of parallelogram. Hop over to my notes here. So rectangles, they are a type of parallelogram. Definitely need to know that. What makes them unique? Because they are a unique type of parallelogram and they have some unique characteristics that most parallelograms do not have. So the first thing that rectangles have true about them is that they are parallelograms where all the angles are 90 degrees, also known as right angles. So all 4 corners of our parallelogram are right angles. Obviously, all of the characteristics of a parallelogram are still true. So in a rectangle, opposite sides are parallel. Opposite sides are congruent. You can see that here and here. Opposite angles are congruent. Even consecutive angles are supplementary because 90 plus 90 is equal to 180. But what makes them unique is they have 90-degree angles in every single corner. And so that's kind of your key piece of information for that characteristic. The other thing is like in parallelograms, the diagonals bisect each other, but more than that, both diagonals are the same. Now, if you remember with parallelograms, it wasn't true that these 2 diagonals were the same length. They're different lengths. But in a rectangle, the 2 diagonals are the same length. They are the same length to begin with, and they still bisect each other. So one thing to remember is that all of the characteristics from the previous lesson of parallelograms apply to rectangles. These 2 that I've shown you here, these are just what is unique to rectangles. So I just want to make sure you're aware of that. This lesson is unfortunately mostly proofs. So like I said, I promised I would work through the proofs and have you follow along. So please follow along and kind of listen to the process. And again, as we approach the test and there is one question about a proof on the test, I will make sure that you're prepared for that. But yeah, we're just going to work through this together. So it says, given ABCD is a rectangle. So they're telling us this figure, ABCD, is a rectangle. Great. So that is our given. Then it says, number 2, angle A, angle B, angle C, and angle D are right angles. Okay, how do we know that? Well, we just learned that. We just learned that because it is a rectangle, all of the angles are right angles. So that's going to be the definition of a rectangle. And there it is, answer choice E. The definition of a rectangle says that all of the angles are right angles. Next, it says that A is equal to C and B is equal to D. Well, we obviously know that because all right angles are congruent. So there's no reason to assume anything else. If these are all right angles, then they have to, A and C, B and D have to be congruent. And so that's what we call the right angle congruence theorem. It says right here, we are talking about congruent angles, and here is a property that talks about congruent angles. Common sense, that one must match up with the statement about congruent angles, and it is that, B, the right angle congruence theorem. All right, it's pretty easy. And then that's it. We don't need anything else because then we get to ABCD as a parallelogram, which is what we were trying to prove. And that is proved by the fact that opposite angles congruent, that is a characteristic of parallelograms. So if B and D are congruent and A and C are congruent, then that means this is a parallelogram, which we already knew, but this is a proof to show how this leads to it being a parallelogram. All right. All of this information in the lesson is illustrated here on the notes, just so you know. Next one. Now it's going to deal with diagonals. You can already see. Given ABCD is a rectangle. Okay, makes sense. We want to prove this, that these are congruent. So we need to prove, we're trying to prove this property of rectangles. Okay, interesting. So we are given the fact that it's a rectangle. Then we say ABCD is a parallelogram. How do we know that? Well, because rectangles are parallelograms. Again, we've proven that up here. That was what we just got done proving. So that's the next statement. Then it says AB is congruent to CD. And that is the fact that opposite sides of parallelograms are congruent. Opposite sides of parallelograms are congruent. That was something we learned in the last lesson. Okay, so far so good. Then it says AD is congruent to AD. I've said this in the past, but anytime you have something that's equal to itself, we call that the reflexive property, always, because it's a reflection. AD and AD on either side of the congruence. Anytime it's the same thing, it's going to be the reflexive property. Then it says BAD and CDA are right angles. Let's find where those angles are. BAD, and CDA are right angles. We can see that here and here. Okay? Well, that's just the definition of a rectangle, because all rectangles have that as a characteristic. That is the first characteristic we learned about rectangles. Sorry, I'm just trying to erase everything. All right. Sorry about that. Let's clear all my drawing here. There we go. All right. Then it says BAD is congruent to CDA. Well, those are the two we just talked about. And since they're right angles, they are congruent. That's what number 6 says, the right angle congruence theorem. Then it says the same thing again. That is a little bit of a strange statement. And I believe that that is a typo. Good thing I caught that. This should say triangle BAD is congruent to triangle CDA. And we have proven that because if you look above, we've proven that two sides are congruent, side, and we've proven that an angle is congruent. And the only way to combine those into a triangle congruent statement is going to be SAS. And there it is right there. Sorry about that. That's why we're doing these together. And then lastly, we've proven that AC is congruent to BD. And I said this in a previous video. Anytime you prove that two triangles are congruent, and then the next statement is to say that parts of those triangles are congruent, you are doing CPCTC, which stands for, again, congruent parts of congruent triangles are congruent. Anytime you have triangle followed by something, either an angle or a side, you're doing CPCTC. All right. Well, let's keep going because we got a couple more here. Complete the proof below. I don't know why this one is arranged this way, but we're going to work through it together anyway. Complete the proof. AC is congruent to BD is our given. I don't know where the diagram is, but it's somewhere up here. I think it must be figure 3.7. I think this figure is what we're using for proof in number 3. So I'll use this as our diagram. We're given AC is congruent to BD. Then it says AB is congruent to CD. So AB is congruent to CD. Well, that's going to be the fact that parallelograms opposite sides are congruent because AB and CD are opposite sides of a parallelogram. So let's go down here. This is where it gets a little confusing. We got all these letters, opposite sides congruent. That's C. Next, AD is AD. We already talked about this. Always reflexive, B. Anytime it's the same thing congruent, you're going reflexive. Reflexive property of equality or congruence. Then it says to prove that SSS is the reason. They've given us the reason and not the statement. Well, we already know that anytime we're using SSS, SAS, ASA, SSA, there's a bunch of different combinations. These are all going to be triangle-related statements. SSA is not an option, actually. It's AAS. So I'll write those down. The options are SSS, SAS, ASA, and AAS. Any of these work to prove that triangles are congruent. So we know this is going to be a triangle statement. The only triangle statement down here is A. BAD is congruent to CDA. And then we just talked about this in the last one. We do a triangle and the next statement is something else. We know that we're doing congruent parts of congruent triangles. That's answer choice D. Every time. Anytime you do triangle, the next statement. If it's an angle or a side, you're doing CPCTC. All right. Then it says BAD and CDA are congruent. So let's hop up to our picture. BAD and CDA. BAD and CDA. Those are consecutive angles. And this is a parallelogram. And so we know that in parallelograms, consecutive angles are supplementary. That's going to be J right there. You should see that, J. And there we go. And then it says BAD and CDA are right angles. Congruent supplementary angles are right angles. E. Right angles. For if there is any congruent supplementary angles, automatically assume they're right angles. It's the only way for two things that are the same to add up to 180 is for them to be 90. Next one is written for us. BCD angle and angle ABC are right angles because in all parallelograms, opposite angles are congruent. And then it says, therefore, ABCD is a rectangle because that is the definition of, I wonder if it's the definition of a rectangle. It is, because that's what we're trying to prove. The definition of a rectangle is G. All right. So that gets us through our proofs. Thank you guys for sticking with me on that. I'll leave that right there for you to get those correct responses, but make sure that your answer choices are the same. After that, the rest of this is you looking at the theorems and matching up the correct definition. So I'm going to let you do that. All of this information comes from the unit, from the lesson. I've discussed everything written right here in my beginning of this lecture. So make sure you maybe jump back there and listen. And I'll also post the diagram where it shows the different relationships between different types of quadrilaterals. So you should be good to go for this lesson.